Hey students, this video is going to go over how to calculate the partial pressure using mole fractions. So we've already talked about Dalton's law of partial pressures, which said that the total pressure of a mixture of gas was equal to the partial pressures of each gas that was made up of the mixture. Well, this is how we would determine the partial pressure of a specific gas if we only know how much gas is present in the total pressure of the mixture itself, okay? So again, N is representing moles. So you would take your total pressure times the amount of moles of a particular element you were looking for, divided by the total number of moles of the mixture, and that would give you the partial pressure of that particular element. Okay, so if it's asking for the partial pressure of all of the gases, you would have to do this equation several times to solve for the partial pressure of each gas. So let's see how this looks here. So we have a mixture of 2 moles of hydrogen and 3 moles of helium, and that mixture exerts a total pressure of 3 atmospheres. This question is only asking for the partial pressure of the helium. So you can see that we have a total pressure and we have the amount of gas. So if we have the total pressure and the amount of gas, we're going to use that partial pressure with mole fraction. So that means that our total pressure, which is 3 atmospheres, is going to be equal to the number of moles of the element that we're looking for, in this case helium. So 3 moles of helium divided by our total number of moles, which is 5, because we add those moles together. So we would have 3 times 3 divided by 5. So that would give us 1.8 atmospheres, but we can only unfortunately have 1 sig fig in this question. So our answer would be 2 atmospheres. That would be the partial pressure of the helium. Looking at this next question, our atmosphere is a mixture of gases, 79% nitrogen gas, 20% oxygen gas, and 1% argon. What's the partial pressure of each gas in the atmosphere? So first off, if it's talking about atmosphere, that means that our total pressure is going to be 1 atmosphere. Okay, so we can make that assumption. Now, it doesn't really tell us amount, it tells us the percent, which is a different way of representing how much of each gas that we have. Now, in this particular case, kind of going back to how we did empirical formulas, we would take the percent of each gas and treat it like that was out of 100 grams. So that means that we have 79 grams of nitrogen, we have 20 grams of oxygen, and we have 1 gram of argon. Now, I'm just going to do this because I don't want to do these 1 sig fig kind of things. I'm just going to put a 0.0 here to get me up to different amount of sig figs, okay? So I have to divide each of these by their molar masses in order to get my moles. So I'm just going to set all of these up first, and then I'm going to go ahead and calculate. I don't know why I made that line so long. Sorry, my moles look funny. It's all there, MOL. So 79 divided by 28.02, that gets me 2.82 moles of N2. 20 divided by 32 gives me 0.625 moles of O2, and then 1 divided by 39.95 gets me 0.0250 moles of argon. So I'm going to add all of these together to get my total amount of moles. And that's going to give me 3.47 moles total. So then remember, in order to find the partial pressure of each gas, I take my total pressure, 1 atmosphere, multiply it by the moles of that specific element, and divide it by my total moles. So I would have my 2.82 divided by my 3.47. And that gives me 0.813 atmospheres. That's my partial pressure of the nitrogen. I'm going to write it down here. Sorry, that's a little lopsided. I'm going to do the same thing for my oxygen. I have 1 atmosphere, and I've got 0.625 moles divided by 3.47 moles. So this is going to give me again my partial pressure of my oxygen. And that is going to be 0.180 atmospheres. Whoa, that was way off. Then lastly, I've got my partial pressure of my argon. So I have 1 atmosphere. I've got, not equals. I'm going to be multiplying that by my amount of moles here of the argon over my total moles. So that's going to give me the partial pressure of my argon. And I will have 0.00721 atmospheres. So again, we're going to use this equation when we are given the total pressure of a mixture of gases and the amounts of each gas in that mixture, okay? So when you're working on those packet problems, if you have any questions, just go ahead and let me know. All right, thanks.